this seemed impractical of like transporting, like we need salt water, so we need to be transporting salt water to space. It just seems way too impractical, it costs way too much. And so what we finally settled on was a saltwater furnace, which is you have this, you get like maybe solar panels or hydrogen a plant, and then that's what we came up with. We used the hydrogen plant. You could get energy from that, and it powers your RF generator. With this, you could bombard the salt water with it, and then you have a hydrogen release, and then this hydrogen could be burned, and it could be the heating source of your house, say, be used in a furnace.
And this is our problem statement. Since the 1950s, the U.S. has increased its use of crude oil and natural gas, increasing the consumption of crude oil and natural gas from 6 million gallons to 18 million gallons per day. This combined use will eventually deplete the non-renewable resources of the United States. So basically, we're trying to find a new green way of powering a simple house furnace.
Okay, given our problem statement, our goal was to design a saltwater-powered furnace to heat the house. The power comes from a hydroelectric plant that provides electricity to a radio frequency generator, and then the generator then allows the salt water to burn and produce a flame to make the heat in the house. Some justification is the Energy Department predicts that by, or that in the winter of 2012 that just passed, a price of $3.79 a gallon for crude oil. So that's like very expensive. And then nationwide, an average of a little over $2,000, so $2,000 and $298 would be spent on oil heating. And Americans are expected to spend 3.7% more than last year. And that's just simple. Some are simply too far from pipelines or too expensive to lay down, which is why we created this furnace.
So to add to her that last point, like many of the homes around here, they use either natural gas or like electricity. But if you go like to more, I guess, farther out to the Great Plains, where it'd be really hard for these pipelines to be laid down because houses are so far apart, it just costs way too much. Like in one article, I saw that for a single house, it could cost up to from anywhere to $10,000 or even to a couple $1 million just to lay down new pipelines for either natural gas or to convert their house to like electricity. It seems way too expensive to do. And so other methods that we came upon when we researched was hydrolysis, which is chemically separating H2O into hydrogen cations, H+, and hydroxide anions, which is OH, and this is basically just creating an acid and a base. And next is electrolysis, which is using direct current and then running it through two electrodes that are in the water, and this way the electricity passes through the tubes and therefore releasing H2 and O2. And the third one is thermolysis, is a separation of H2O, and where this happens in the vapor phase, and through conventional heating methods such as conduction and convection.
We were expected to get other input from other people. So Jonathan Harden from NIST quotes that they should be immediately disabused of any hope that this machine would yield a practical engineering solution for anything. And when we asked Alan Leifer, who's a physical chemist, he said, "I simply don't believe that it is the RF that is disassociating the water."
And with this expert consultants, we were discouraged to hear this from them, but despite their comments, we believe that we should go forward as a group because like they didn't exactly know the full extent of our research and how much we've looked into it, and so we believe that they didn't have a full grasp on the concept that we're trying to get at, and we just decided to go forward with it. And so how it works, the process is called electromagnetic dissociation, which applies electrical energy. In this case, it'd be electromagnetic radiation, which comes from the RF generator. And it causes the water in the liquid phase to dissociate into its components. And so RF generator the frequency that we will be, that I'll discuss later, the frequency that is set at, that bombards the salt water, is the natural frequency of the sodium ions, and therefore causing the positive ions to vibrate intensely. This, added with the van der Waals forces of the sodium attracted to the oxygen of the water, and then, of the molecule, and then, oh, excuse me, the van der Waals forces cause the sodium ions will attract, it's a very weak kind of attraction of the oxygen on the water molecules. And this process is similar to electrolysis, where I don't know if you can really see that, but the two half equations are listed right here. And so, as I was talking about the van der Waals forces earlier, here you have the sodium attracted to the oxygen, and the same goes for the chlorine attracted to the hydrogens. And so this attraction added with the natural frequency of the sodium vibrating is enough to break off the hydrogens, to break off the oxygen and release the hydrogens. So here's a demonstration of what's up.
From your backyard. Right. When I visited John, Kansas earlier this year, I wanted to talk about his work trying to find a cure for cancer. But before we got down to business, he wanted to show me something else that his machine can do. I scooped up some salt water from the canal behind his home and brought it into his garage where his radio frequency machine sits. So I'm just going to take this water. How much do you want me to pour in? All the way up. All the way up to the top. Okay. He grabbed a paper towel and put it in the test tube to act like a candle wick. So all that's in this test tube right now is the salt water I just took from your backyard, right, and a paper towel. Paper towel. He put the test tube in the machine, then turned it on. Got it?
And so that's a demonstration of it working, and the person that you saw doing it, that was actually the inventor of it. He's the one that was researching cancer, and he stumbled upon this by accident, which is how a lot of inventors and scientists stumble upon things. And so here's kind of a flow chart of how it works. You start with the saltwater solution, and then you provide the RF transmitter, and then you set up the receivers and everything that goes with it for the RF generator, and then you run it, and then after you run it with the selected correct frequency, and then it will, then you could release the hydrogen, and you can collect it and do whatever you want to do with it. And so here's a diagram of it working at different concentrations of sodium chloride from 0.3 to 30% concentrations. This diagram right here, labeled A, is a 0.3 concentration of sodium chloride in the water solution, and the sort of test tube that you use also affects it. Which in this case it was a Pyrex test tube, and the next one, B, is 3% NaCl, and then C would be 30%, all in the same test tube. That one does 30%, and then D right here is 3% using a different kind of test tube. It's called a PTFE test tube, and E is another 3% using a silica glass test tube. And then F, as you see, there's no flame. That one was used using distilled water, so you can't do this with distilled water. And so this is the wavelength that is that they measured. Like many say that when you burn hydrogen, it's colorless and odorless, but with this, why you see this wavelength, which is in between the range of orange and yellow, you see that because when this process happens, a little bit of the sodium is released, and when sodium burns, it's got this orangish yellow glow to it. And intensity loss, like many people are skeptical about like having, it doesn't follow the first law for thermodynamics, Well, this shows that before, the intensity is in arbitrary units. But as you see, the intensity definitely drops from before and after the exposure, which shows that it has to follow some sort of energy loss, which we know it has to happen in order for it to actually happen. And so we talked about using salt water, but there's plenty of different salts that you can use, different combinations. But we chose NaCl because it's regular table salt. It's very abundant, and almost 72% of Earth is covered in salt water. So there's like an enormous amount of like resources that you could draw from. And so here's a chart of just different concentrations. I know this might be a little hard to see, but I got this off the patent, so this is the best I could do, sorry. But this is different concentrations with different sort of salts, and kind of tells you the power of the RF generator and observations, and whether it combusted or not, and so forth. So our quantitative analysis. The RF generator, the frequency has to be set to 13.56 megahertz. It has to be that specific one in order to be the natural frequency of the sodium ions. And the RF generator requires 600 watts to be powered. And we said we could do it from the Hoover Dam, because it's like the most famous around. But you could pretty much do it from any dam or any sort of resource, maybe solar if you even want to, if you could provide enough power. But we calculated that the Hoover Dam, it produces about 4.2 billion kilowatts per hour, and it services about 1.3 million households. So therefore, it would be about, if it was evenly distributed, we'd say it'd be about 3,230 watts per hour, which is sufficient enough to run our 600 watt generator. And the flame approximately burns at 1,600 degrees Celsius, or almost 3,000 degrees Fahrenheit. Yes, this number may seem rather high, but there are ways to like contain this heat and then maybe even use it in other areas where you need be. And so here's our design.
Alright, so this is an overview of what we're trying to accomplish here. So this is the Hoover Dam right here, and here's the water reservoir. As the water goes through a tunnel under the powerhouse, it goes through a turbine, and which sends the power to the power distributor, the local power plant. And from the power plant, the energy goes to the household, which there runs our RF generator. And here's a close-up of our sketch. As the power is this is the power from the Hoover Dam, and it generates, as we said, that it is at 13.56 megahertz for our RF generator to combust our table salt and water mixture. And from here, the flame would go into the house furnace, and then power and heat the whole house.
So our conclusions and recommendations. So the environment, like the engineering environment that we're working under, is that this venture capitalist and inventor approached Ms. Yates, our CEO, with this proposition of this project, or this possible project. And she assigned it to my group, which is the three of us, to research whether this idea would be too risky for our company, like in terms of like monetary, like would it cost too much, would it be a waste of money, is it even safe, and things like that. And so what we will conclude is that the product appears to be promising. However, there needs to be more time to conduct research to come to a definite conclusion. At the moment, with the information that we have, the problem is too risky, but with more time, we believe it is a logical project to go forward with. And so we recommend that we are given more time and time to research and develop our and figure out how everything is going to come together, because this seems like a very ideal way of going green, and it's rather important in our kind of, I guess, our kind of situation that we're in with natural resources depleting. And so that is our conclusion recommendation. And acknowledge